So hello and welcome to another video from sickmaths.co.uk, where you can find us of free maths videos. For some reason the title is in the middle over here. So recurring decimals to fractions. We're going to turn these kind of things that go on forever, recurring decimals 0.22222 or 0.44444, all the way into a lovely fraction like that. So how do we do it? Well, this is the standard method. Once you get it, it's quite easy. It's just like repeated all the time, the same sort of method. So you're going to change 0.3 recurring to a fraction. So 0.3 recurring means 0.333333, as I've kind of shown you how recurring decimals work here. Maybe I should talk about that first then. 0.2 recurring looks like this, 0.22222. 0.4 recurring equals 0.44444. 0.32, where the dot on top of the 3 and the 2 is 0.32323232, and 0.153, where there's a dot on top of the 1 and a 3. That means everything between here and here is recurring. Goes like this: 0.153, 153, 153, because that's recurring. So now you know what recurring means. Let's get on with the real stuff. So change 0.3 recurring to a fraction. This is the standard way you do it, and you'll do the same process for the other ones. X equals 0.3 recurring. So we call x our 0.3 recurring. And what happens if you do 10x? So 10x will be 10 times as much as that. So 10 times that just means move the decimal place one place, and now it becomes 3.3333 going on forever. Okay, so because there's obviously lots of 3's going on forever here and there. So when I put a 3 here, I move the decimal point there, there are lots of 3's to follow behind it, which is including these 3. So basically times this by 10, you get that. Okay, and so 10x equals 3.3 recurring, and x equals 0.3 recurring. I do this one, take away this one, so 3 take away nothing is 3, and 3 take away 3 is nothing. And because it's 3 recurring endlessly, yeah, there's a 3 there and there's a 3 there, so that becomes 3 take away 3 is nothing again. So basically you end up with just 3. Yeah, with this 3.3 recurring take away 0.3 recurring is just equal to 3. And what's 10x take away x? Is 9x. So now we've got 9x equals 3. And if you rearrange that, bring the 9 from there to there, it goes underneath, and you get x equals 3 over 9, which is simplified as 1/3. So we know x is equal to 1/3. Well, we also started with the fact that x equals 0.3 recurring. Therefore, if x equals this and it equals this, therefore that equals that, because x equals both of them, so x is this and that, and so they equal each other. So that's the idea behind that. So number 2, as promised, is very similar to this, except for we've got 2 numbers recurring. So if we've got 2 numbers recurring, we need to do a slightly different trick. Instead of just doing 10x, we do 100x, and here's the reason. If we just times by 10, okay, you would get 6.161616, which means the 1 would be here above the 6, and when you come to doing the taking away, it wouldn't be so nice. You couldn't just make them disappear. The whole point of this method is to get rid of the recurring bit, because that's the confusing bit, isn't it? Okay, now we've got 100x. What we've got is 61.6161, because you had to move the decimal place 2 places, by the way. When you times by 100, you move the decimal place twice. So you move it once, twice, and then you got 61, and then obviously because it's 61 recurring, you got another 61, 61, 61 after the decimal point. Yeah, so move it once, twice, you got a decimal point there, you got 61.61 recurring. Anyway, so which is what we've got there. So now you've got that, and this is really a lot more comfortable, because the 1's on top of the 1, the 6 is on top of the 6, and it goes on forever like this. There's another 6 there, there's another 6 there, there's another one there, there's another one there. Okay, and we're taking them away. So you got 61 take away nothing is 61, and the 6 1 6 1 6 1 6 1, take away 6 1 6 1 6 1 6 1, basically cancels each other out. So 6 take away 6 is nothing, 1 take away 1 is nothing, as we had in this case. So you end up with 61 here, and 100x take away x is 99x. So 99x equals 61, and rearranging gives you x equals 61 over 99. I don't think that can be simplified. Doesn't matter if you can or can't in this case, because all what I want to show you is that we've turned it into a fraction again. So x equals 61 over 99, but it also equals 0.61 recurring. Therefore, these two equal each other. Okay, so that is that. So that is the answer for that question, by the way, and that is the answer for this question. We've turned it into a fraction in both cases. This one's slightly different, same method really. We've only got one number recurring, so we still do 10x. The thing that's different about this one is you notice the dot starts from there, not from the 5. So it actually becomes 0.5444444444. Okay, so only the 4 bit is recurring. So 5 is in the beginning, but the 4 recurs forever after that. So if I times that by 10, that means move the decimal place one place, and you get 5.444444. Now, just to make it sort of visually easy, I just didn't bother putting the recurring bit there. I put the recurring bit there so you can easily compare it to that. So now you've got 5 take away nothing is 4. No, sorry. 5.4 take away 0.5, yeah, is what? 4.9. Yeah, and 4 recurring take away 4 recurring is nothing. Okay, so then forever after that you've got nothing. That's all gone. Okay, so 5.4 take away 0.5 is 4.9. And 10x take away x is 9x, so 9x equals 4.9. Rearranging gives x equals 4.9 over 9, which is almost our answer, but it's not a proper fraction. You can't have decimals in the fraction, can you? So you times top and bottom by 10 to make that whole number. That makes it 49. Times that by 10 gives you 90, and you got your answer. So x is equal to 49 over 90, which is also equal to 0.54 recurring. So that means these two, this number has been changed into this fraction. This is equal to that fraction, and that's it. Anything else? No, not really.